Alright, so last lesson we converted from mixed to entire radicals. What we're going to look at today is the other way around. So you're going to get a question that'll look something like that. We'll have 45x squared y to the fifth, and we're going to have to convert it into something that's 3xy squared root 5y. So it's basically the exact same thing we did yesterday, except it's reversed. So what you have to do is basically start, instead of squaring it, so normally we would take the 3xy, we'd write that as 9x squared y to the fourth, and times it by 5y to get our final answer. So the trick is, what do we need to break that down into to get that 9x squared y to the fourth part? So what we're going to do is just quickly review yesterday. So remember, when we had something like this, we would change the 3 to 9a squared. We'd square both of them, and then have the 5 as sort of our leftover. So then when we multiply them, we get 45a squared. So you can see the backwards process is we need to change the 45 into root 9 and root 5. So the challenge is deciding what do you break it into. So the next one, same thing. We'd have root, our cube root, so it'd be 125 5 times 5 times 5 is 125, x cubed times root 3. So that would give us negative 375 x cubed. And our last one, we'd have 1/9 x to the 6. So 27 times 1/9 is 3. So this one's going to be a tough one. It's almost impossible to work backwards for that one. But the other two, we should be able to actually do the simplifying to get it back to what they started with. So that's our goal today, is to figure out how to do that. So the first step is you need to convert your mixed radical. You need to figure out what factors that radical will break into. So we won't worry about the variables just yet. Let's just look at just the regular number. So if I gave you root 72 and I say simplify that, we could break it into 9 and 8. That's possible factors, or 12 and 6, or 18 and 4, or 24 and 3, or 36 and 2. So we've got 5 different options here. So what's the best way to go? Well, some of them are going to work easy, some of them will be a little bit more difficult, and one of the group is going to be the best. So what we want to do is always choose the largest perfect root. So I have a perfect root chart that I gave you in class, and I have it posted on the Moodle site. So what you want to do, remember, is use that list. So we know that for 2 is equal to square root of 4, 3 is square root of 9, 4 is root 16, 5 is 25, and so on. So we want to go through that list of numbers and pick out the biggest one. So if we were to look at our last page here again, so if we were to look at all of our different factors, we got 9, 12, 18, and so on. So 36 is the largest. So that's the one we want to choose. So you want to pick the perfect root that's the biggest, which is 36. So you have 36 times 2 would give you 72. Then the root 36 breaks into 6, a regular 6, and we're done. So root 72 simplifies to 6 root 2. If we would have chose a different one, so let's just pick the top of the list, the 9 and 8 one, it'll still work, it'll just take you quite a bit more work. So root 9, root 8, break the root 9 into 3, so that gives us 3 root 8, but the root 8 can still be broken down, so we can change that into 4 and 2, root 4 would be just a 2, so we'd have 3 times 2, which gives you 6, and you get 6 root 2. So you do get the same answer, but quite a bit more steps and more things that could go wrong. So the best advice is always choose the largest of the perfect roots, and you should find your answer quite a bit easier. So let's do a few examples. So square root of 320. So what you want to do is look on your perfect root list and pick the biggest root that divides into 320 evenly. So obviously it can't be bigger than 320, so our list would be limited to, start at 17, 289, so that's not going to work. It's got to be at least half of that, so we can go down to like 160 range. So it's got to be less than 144, 121 doesn't work, 81 doesn't work, 64, 64 and 5 work, possibly. Let's try that. So if you're not sure, you just basically have to type these in on your calculator. So go 320 divided by 64. 64 and 5, that's it. So I picked the biggest one because 5 can't be broken down any further, so we're good. So root 64 is the same as 8. So 8 root 5 would be your final answer. So now when we do cube roots or something like that, you just got to pick the cube root list. So out of 108, we got to divide by 108. So does 64 work? 108 divided by 64? No. Does 108 divide by 27 evenly? Yes, it's 27 and 4. So we'd have cube root of 27, cube root of 4. Cube root of 27 simplifies to just a regular 3. So we'd have 3 times cube root of 4 as our final answer. Okay, next one, same thing. We got 6,000. That's an easy one when you look at the list. 1,000 is on there, so 1,006. Cube root of 1,000 is 10. So we have 10 times cube root of 6. Now let's do one more, our fifth root. So we got 486. We see that 243 is on there. So 243 and 2. And fifth root of 243 is just a regular 3. So it works well with just regular numbers. So you just want to remember to pick the biggest one on the list possible, and then you only have to do one step. Otherwise, you're going to have to do it more than once. So let's try a couple more, but with variables this time. So what we want to do is break it into 2 roots again, just like we did. And let's just do one at a time. So worry about the regular numbers. So we have 50. So the biggest on our list that'll divide is 25. So we have 25 and 2. Now what we want to do is deal with the variables. So because it's a square root, the square root of x squared is just x. Those cancel out. Square root of x to the 4th is x squared. Square root of x to the 6th is x cubed. So really what we're doing is we're just taking the outside root number and dividing it by the index. So 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. So that works well. And then if we had cube roots, we have to have multiples of 3. So cube root of x cubed is x. Cube root of x to the 6th would be 2. Right? We're still dividing. 6 divided by 3 is 2. Cube root of x to the 9 would be x cubed, and so on. So for square roots, we want to pull out 2, 4, 6, 8, and so on. Cube roots, 3, 6, 9, 12. Fourth roots would be 4, 8, 12, and so on. So what happens if you can't pull them out? So in this case, we have a square root of x squared, so that will work. So we want to take out all of the x squareds. So now when we do our square root, we get 5x root 2. So the first one works good. The second one, not so good. So if we take care of the 60, so we'd have 60 divided by 9 doesn't work. 16 divided by 4, I think that's the only one. Yeah. So we'd have root 4 and root 15. Now we have an x cubed. So because it's a square root, we can take out 2, 4, 6, but we can't take out odd numbers. So what we want to do is take out what we can, the biggest one, so x squared, and then we'd have 1 left over. And we have a y, we can't take out 2 out of the 1, so it'll just stay as a leftover. Okay, so you just want to pull the biggest one out of that number. So if it's a square root, we want to take out the biggest multiple of 2, which in both these cases would just be 2. There's nothing bigger than that. And that's it. So to simplify the first one, we get 2x, and the second one would stay as 15xy. So our last one, we got a half. Leave that out for the time being. And now we got to break down our numbers. So 320. 320 won't. What does it divide by 81? Let's check. Nope. 320 divided by 64. Yes. So 64 and 5. And now in terms of the roots, so we got a square root. So we want to pull out 2, 4, 6, 8, whatever we can. So for the x's, we can take out 2 and have 1 left over. For the y's, we can take out all 4. That's okay. And for the z's, take out 4 and have 1 left over. So now when we simplify our first root, we get 8x y squared z squared. If we square root all of those. So all we have to do is times that by half. So we'd have 4x y squared z squared times 5xz in the root. Okay, so be careful with the letters, but it's easy. Just think of it as pulling out multiples of whatever that index number is. So let's do a few more, but using cube roots. So cube root of 54, so we could take out a 54 would break into 27 and 2. And we have x squared. We need to take out multiples of 3. There is no 3, so the x squared would be our leftovers. And that's it. So cube root of 27 is 3. So our final answer should be 3 times cube root of 2x squared. So our next one, I'll write it down here so I got a little more room. So we do cube root of 3,000, so we want to do 1,003. X cubed, we can take out all 3. So put it out front, and we'd have nothing left over, so that one will simplify to 10x. And then cube root of 3 would be our leftovers. Next one, 4th root. So leave the negative 5 out for the time being. 162 and is a 4th root, break into 81 and 2. And we have x to the 6. We want to pull out multiples of 4, so we'll take out 4 of them. And we'd have 2 left over. So our next step, 4th root of 81 is 3, so we'd have 3x. So 3x times negative 5 would be negative 15x, 4th root of 2x squared would be our final answer. And the last one, same idea, but we're using 5th roots. So we have negative 160, so as a 5th root, 160 divided by 32 is 5, so we'd have negative 32 and 5, and it doesn't really matter where we put the negative. And then we have x to the 6, so we can take out 5 of them and have 1 left over. So our final answer, root of 32 would be just 2, but we'll have negative 2, and then x, and 5th root of 5x would be our leftover. And that's it for today.